Yes, class. Am I audible? Khalid
Yes.
has also joined here. Left. Salman, Sumaira, and Zaid. Fine. All right, class. In the last class, we had started with LCR circuits and major portion of AC alternating currents we had completed among the AC circuits. Few circuits we'll do more today, but before that, let us just quickly revise LCR circuit and let's do certain numericals on it. Though I had given you some of the numericals in your assignment. So Khalid, I have received. What about others who all have submitted? I don't remember. Khalid, I just remember Khalid had submitted the assignment. Among you three, did you try the assignment? Zaid, Salman, Samaira.
Yeah, I submitted.
Salman also? All right.
Yeah.
And what about you both, Samaira and Zaid?
No, ma'am, I submitted today.
Okay, Samaira. Okay, Zaid also. Fine. Good, good. Then you will be able to understand the class better. Samaira, try to complete it today or tomorrow. Fine. Before the next class. Next class is on Wednesday, so try to complete it. Now, LCR circuits, we had started. LCR circuits were the combination of a resistor, inductor, and capacitor, all three connected in series. In case of resistor, we had already studied that current and potential were in the same phase with 0-degree angle between them. For inductor, we had studied that potential for the inductor leaded the current by 90 degrees, whereas it lagged for a capacitor by 90 degrees. This much we had done. So when we combined all these phenomena, we had to have two cases. The two cases included whether potential's value for inductor is greater than capacitor or capacitor is greater than inductor. Based on this, we had concluded this formula. Z is equal to under root R square plus either it's XL minus XC whole square or it's XC minus XL whole square. You can remember only one formula. It's just that to avoid the negative sign that you can even analyze by your own, whichever is greater, to subtract it to get a positive sign that you can get by your own. So Z is important. Z here is the impedance. Impedance means the net resistance of the LCR circuit. Whatever is the effective opposition that will be offered. And then tan phi also we had seen. So you can use tan phi as well. You can use cos phi as well whenever phi is asked. Phi is what? Phi is the phase angle. So whenever in the question anything is asked, you can use these. Fine, tan phi, you can write cos phi. It depends on your need. If you have the value of impedance, you can calculate the value of impedance. If you have impedance and resistance with you can easily get the value using cos theta. If you have XL and XC, then you can easily find out using tan theta. It depends on whatever you have. And remember, whenever XL is greater than XC or XC is greater than XL, because these two only get subtracted. Resistor is of no use in finding these. Ultimately, at the end, you have to find out the resistance. Now, one case we did, which we called as the natural or resonant frequency, that is the resonance condition of LCR. Here, the important thing that included was this. XL is equal to XC because the current was maximum at this point. So current will only be maximum if you reduce the resistance. If you reduce the resistance and allow the current to flow, then only current will be its peak value or its maximum value. So XL is equal to XC, you have to remember. And from there, you can calculate the value of this frequency, which we call as the natural or the resonant frequency. So if angular resonant frequency is, you can simply use this. If natural or resonant frequency is just divided by 2 pi. So that gives you 1 divided by 2 pi under root LC. So revision also we have done of what we have studied. Today we will see some more circuits as well, hopefully. But before that, a question is there in front of you. Note it down, try it yourself. I'll discuss it in 2 minutes. Not the second part, at least you can calculate the first part because the calculations are easier. For the first part of finding out the current, at least tell me the impedance. Z, at least you can tell me. Because the calculation is easy, you'll be able to find out the value of Z, though it is in under root. Just try and send me your answer. At least Z, you all should tell me. Yes, Z, correct, right value. That's the value of, I think, Z that you must be getting. Now try to find out the value of current. You will get the current in seconds now. Others also reply. Only Z has actually solved the first part as well correctly. At least tell the value of Z. See, resistance is given, inductive reactance and inductive capacitive reactance is given. Last 1 minute, then I'll discuss. Now class, see, resistor's value is given as 12 ohm. Fine. Now Hania, tell me one thing. Is the value of capacitance given to us, or we have the value of capacitive reactance with us? Hania. Yes, Hania, your answer is right. Answer is perfectly right. This is your impedance. Just answer this. Yes, Hania.
Of capacitance reactance.
Yes, it is capacitive reactance. Correct. This is given as 14. And inductive reactance, this is given as 0.1 Henry. Fine. Pure inductor. Oh no, this is L given. This is written, no, 0.1 Henry. This is not resistance given. It is written pure inductor of inductance. So this is the value of L is given. L is given as 0.1 Henry. Fine. Now, E effective, E virtual, E RMS, whatever you say. Samaira, can you answer what is the frequency and what is ERMS? Samaira? Frequency and value of ERMS. These two things I'm asking.
Frequency is of 50 hertz.
And ERMS? See this adjoining value of voltage, no, along with frequency. This is written what? This is AC supply. So this will be 200 volts. Clear? Now what do we have to find? We have to find the current in the circuit. Current in the circuit means you have to find the IRMS only. Now for finding out the IRMS, we need the value of resistance. But we have a resistor, but we cannot use this only. Here we have to include all the three. We have to find out the net resistance. And what is the net resistance of an LCR circuit known as? That is known as impedance. Z, IRMS, and okay, phase angle also you've calculated. Phase angle, how did you calculate, Khalid? in terms of tan theta, that value you remember?
I referred from the clock
Okay,
table.
okay. Good. Answer is exact. Accurate answer. So what did tan phi come? How much?
1.33.
Check. Good. Even you can leave in terms of inverse trigonometry, that's okay. But yes, good, right. Because in your exams, I don't think so log table is provided, no? Log tables are not allowed in your board exams. Or are they allowed?
I don't know. Teachers are saying they will allow. Some say they don't. I don't know about that. Not sure.
At your places, I'm asking. Here in India, it's not allowed to carry anything apart from the admit card. Just find it out, and because I don't think so log tables even in chemistry are allowed. Chemistry also there's a need of log tables. In maths also, fine. Whatever, just find out. So I think most probably they won't allow you to carry the log tables with you. Or if there is any need, such need, they'll provide their own log tables, most probably. Just a second. Now IRMS is there. So IRMS will be equal to what? Will be equal to ERMS divided by the net resistance, and we have a specific term for the net resistance, that is impedance. Now XL is unknown. Let's calculate XL also. So yes, Salman, was the formula of XL? Inductive reactance. Yes, Salman, in terms of frequency. Frequency is with me. I don't know what is inductive reactance.
Omega L.
But I don't have omega with me.
When 2 pi nu, no?
Yes, 2 pi nu L. This will be 2 pi nu L. Because this part is omega, this becomes omega. So this will be what? This is 2 into 3. It is written, no? Take pi as 3. So 2 into 3 into 0.1 into 50. This will be 10. So 0 cancelled. 3 0. 30, no? Yes, 30 ohms it should be. Just correct me wherever I am. Now Z, value of Z. Formula is under root R square. R square means 12 square. This is 14, this is 30. So I'll prefer 30 minus 14. That is XL minus XC whole square. So Z becomes what? This will be 30 minus 14 whole square. Under root 144, and you'll add 96. 400. 400. Yes, should be 400. Just check. Yes, it should be 400. That's why we'll get 20. All right, this should be 400. So we'll get 20 ohms as the value of Z. Now you can put IRMS. This is 200 volts given. This is 20. So this comes out to be 10 ampere. This is the answer for the first part. Second part is asking the phase angle between the current and the voltage. So rest of the things are clear to us. We just have to find out the value of tan phi. So for the second part, tan phi can be written as XL minus XC and XC minus XL anyways. So right now we have XL minus XC because XL is greater than XC. So we'll write XL minus XC divided by R resistance. So this will again be 30 minus 14. This will be 12. We had already 16 here. 16 divided by 12. So 16 divided by 12, or you can write tan phi as what? Tan phi can be written as 4 by 3. So you can leave your answer at this step also. Phi is equal to tan inverse 4 by 3. In your entrances also, no, these kinds of options are mostly given in terms of 4 by 3, 3 by 4, like this. So quickly note it down. One more question we'll do before we begin with us. A very, very small topic, Q factor, that was left from this resonance and LCR circuit part. Just copy this down. C class, there's a variation. First, just see this graph, then I'll tell you. Questions do come from this part in the sense, what do you mean by sharpness of resonance in a series resonance circuit? Or find the expression for this term, Q factor. So whenever Q factor comes in your exam, just get, you have to mention about the sharpness of resonance. Okay. So you have to mention about the sharpness of resonance. Now, sharpness of resonance or Q factor can be understood with the help of a graph. This is what? This is current. This is angular frequency over here. This is current and this is angular frequency. Now, if I show you a variation of the peak value of current, that is the amplitude of this current. I naught means what? I naught means the peak value, amplitude. So for LCR series, LCR circuit, angular frequency is omega. So three different values of R I can show you. If I draw the graph like this is one value of R that I'll get. This is one more graph that is possible. And the other variation is this. So here what happens, current amplitude is what? Current amplitude has a peak at the resonance. Resonance value was what? Khalid, repeat. What was the value of omega at resonance condition, angular frequency? Yes, Khalid. What was the formula?
For omega?
Yes, omega at resonance.
Sorry, teacher, I don't remember.
See, it was 1 by under root LC. Fine. Now all of you will remember. See, this has arise from that derivation. XL is equal to XC. So omega 1 by omega C is equal to omega L. From there, omega square is 1 by LC. Omega will be 1 by under root LC. This is a small derivation, but it comes in exam. Fine. So the peak value of omega is what? So current amplitude has a peak at the resonance frequency 1 by under root LC and falls to 0 either in either direction. This is a graph that is given in your NCERT and you have to remember this graph also. Questions will not be asked from this graph directly, but here you have to remember. Through experimentation, this was concluded that here resistance was high. Here it was moderate resistance. And this is a very low value of resistance. This is a very low value of resistance. Fine, class. So here what, see, you can even figure it from here. XL is equal to what? XL is equal to omega L, right? So here we have what? We have the value omega R fixed over here. At the most maximum value of current, there will be very less value of resistance. Then only, no, we are getting a very higher value of current. Yes, Zed, you come in, join us. Just let me know when you've joined. Similarly, here for a minimal value of current, we'll be having a moderate resistance. Here the current's value is very less. Current's value is very less as in comparison with others. So here the value of resistance will be more. This is the relation between them. So resonant frequency is independent of R. Remember this fact. This resonant frequency, this is independent of R. As you can see, there is no resistance coming in the formula. There is L, there is C, but there is no R present in the formula. So it is independent of R. So the sharpness, but you know, since though it is independent, but the sharpness of peak depends upon R. Have you noticed this fact? Whether the peak will be sharp or the peak will be blunt depends on the values of R, moderate, high, or low. So we get for a small R, we get for a small value of resistance, we get a sharp curve. For a value of high resistance, we get a flat one. So sharpness of resonance is measured by a coefficient that is called the quality or Q factor of the circuit. This Q, no, that we write Q factor. This is actually the quality factor. Q factor or the quality factor. So this is what I'll write down the definition as well. So for, just remember, this is for a series resonant circuit only. Do not write this Q factor in any of the formula for impedance of any other circuit, any kind of circuits. For simply for series LCR resonant circuit, I'll write it down. Q factor of a series resonant. Remember here, resonant term is very important because we are only able to find it at the value omega is equal to 1 by under root LC. That's why we are having this value at resonance. So series resonant circuit. This is important. Resonant is defined as what? See, it's the ratio of the resonant frequency. It's the defined as the ratio of resonant frequency. So resonant frequency means what? Resonant frequency means this only 1 by under root LC. Now divided by what? Divided by, there's a difference. See, if you see this graph, now you're able to notice two values over here. If you notice this graph, let's take this peak value, this one. If you see here, here will be a value that you will obtain, let's say omega 1, and here also will be a value of frequency that you will obtain omega 2 on either sides of the frequencies, resonant frequency. So the difference between these two, omega 2 minus omega 1, that is what will come in the denominator. So it's the ratio of omega r divided by omega 1 minus omega 2. So it's the ratio of resonant frequency to the difference in two frequencies taken on both the sides of the resonant frequency. Both the side, it's to the difference in two frequencies taken on both the sides of the resonant frequency. Now, one more thing, one more point that will come here is that the current's value, that becomes 1 by root 2. That also becomes 1 by root 2 of the original value in case of Q factor. Whenever we determine the sharpness of the resonance circuit, how sharp is the resonance? Because current falls to 0 in either direction, ultimately. So what we do, we choose the current amplitude automatically becomes 1 by root 2. So such that at each frequency, the current amplitude becomes 1 by root 2 times the value at resonance frequency. The value at resonant frequency. See, again, I tell you what is meant by this. That was the definition. You can copy it down quickly. Here there was a graph. Like this, there was a graph, one of the graphs I have taken. Now, from the center, at the peak or the center, there will be resonant frequency. On either sides of it, there will be values of normal frequency, not the resonant one, but lesser than resonant or more than resonant. Obviously, lesser than resonant because resonance is at its peak value. So let's say this is omega 1, let's say this is omega 2. Fine. This is what? Current versus omega graph. Q factor is what? This is omega r divided by this frequency, difference of the frequency. This this difference that we are getting, this difference, which is what? Omega 2 minus omega 1. Now, what do? We call this term, no, that we get, this separation, we call this as the bandwidth. So in common terms, you can write bandwidth is generally written as 2 delta omega. 2 delta omega means if this is 1 omega, if this is 1 delta omega, so this will also be 1 delta omega. So both of these, delta omega plus delta omega, that will become 2 delta omega. This you can remember. So this is bandwidth. So in word terms, you can remember this is resonant frequency divided by the bandwidth. Or this also you can modify omega r divided by 2 delta omega if you remember one value. And what about the current? There was a change in the current's value as well. Current became what? If at this frequency, at the resonant frequency, at this maximum value, the value of current was I naught is equal to E naught divided by R. At this value, at a certain different value, the value of current will become E naught divided by R was there initially. It will become 1 by root 2 times. That was only written up. This was only, I have written it here. That was the above thing written. So Q factor, I'd read that out. Now, I hope you'll understand now. If any doubts, ask me. So Q factor or the quality factor of a series resonant circuit is defined as the ratio of the resonant frequency to the difference in the two frequencies. Difference in the two frequencies taken on both sides of the resonant frequency such that at each frequency current amplitude becomes 1 by 2 times the value at the resonant frequency. This was what was about Q factor. We'll do a very short derivation also, but before that just note it down. Are you all aware about your half-yearly exams? You know about your half-yearly exams, these Khalid, Salman, Hania, Sumaira, just let me know.
Yes.
When are you having your half-yearlies, Khalid?
I feel like at the end of September or mid of September.
You feel like? No, date is not mentioned right now. Officially, it's not given from your school.
It's not officially given.
No.
Not officially given.
Okay.
Usually it's around end of September and mid of October.
Okay, so right now I think once your school will start, I think by the next week only, no, your school must be starting.
Yes. Next week, Sunday.
Sunday it's starting. All right. So I think you'll be getting the information and the date sheet and all regarding that only. So how much was done before the vacations that started in your school, Khalid?
I think we completed till current electricity
Current
at school.
electricity. All right. So I think maximum chapter 5 should come. So I think it is done over here. Just let me know. And what about you, Hania? Any information regarding your half-yearly exams?
Usually it's in the last week of October.
October?
Yeah.
Okay. It's your 12th, no? So maybe it will be a little earlier. Just let me know. And Samaira, no information as well from your side?
Same as Hania.
Sure. You both are in the same school?
Yes, ma'am.
Okay.
Ma'am, can you scroll up again?
Written till here as well? Or drawing this graph part? Others as well? Done. One small derivation is there. Shall we start with it or anyone is writing? All right. Now there's one more formula for this Q quality factor. A very short derivation, not a very short actually, a derivation is there that we have. The derivation is easy, but in the exam, this is rarely asked. Formula, though it is asked, but the derivation part is slightly, the chances are less. But yes, in one of the papers it has come, so do revise it. So current was what? I naught was equal to E naught divided by root 2R. And at resonance, we all know what is the value of what is the value of impedance at resonance? Can anyone answer? Value of impedance at resonance. Last class we did it on Wednesday. Look into your notes. You must have written in the last part before the lecture had ended in the last class. Nobody remembers. See, XL and XC got cancelled. So under root R square will be what? R only. Impedance is actually equal to resistance. So here in this case, Z will be equal to root 2 times R because the resistance has become root 2 times. Now if you put the formula of resistance formula, that is R square plus omega L minus 1 by omega C, that is XL minus XC whole square. This will be equal to root 2R this time. Agreed? This is what? This is Z, XL minus XC whole square. This is the value of Z at resonance for this case, for the quality factor for calculating the sharpness. Now from here, if I square all the terms, both the terms, this becomes R square plus omega L minus 1 by omega C whole square. So square gone. And from here it will be what? 2, and square of R will give you R square. I have squared both the side. On squaring both the sides, I obtain this. From here, 2r square minus r square will give me r. So omega L minus 1 by omega C whole square will give me r square. From here, r will also under root I'll take, so I'll get value omega. This is looking as if inductance is getting multiplied. Class, remember this is in the, see here this is getting multiplied, omega L. This is not written as XL or XC were written. So this is what omega L minus 1 by omega C. This will be equal to what? Plus minus R root I have taken from here. Now from here, if I separate both the terms, one equation that I'll get will be omega L minus 1 by omega C is equal to plus R. Other term that I'll get will be omega L plus, minus 1 by omega C will be equal to minus R. So one equation, second equation. Clear till here? Right now, I've just opened up these two by squaring them on both the sides. So now using these two equations, I just have to use these two equations twice to get the final answer. One is by adding. If I add 1 and 2, see what will happen. If I add both of these, no. From here, see, this will be omega 1. This is for the first one I'm writing. Now I'm separating them, and this will be omega 2. If it is omega r, then it will be omega r has one value. So I'm writing this as omega 1. This is omega 2 on either sides. Now, if you add it from here, omega 1L plus omega 2L. L can be taken common. So omega 1 plus omega 2 into L. Fine, class. Omega 1L plus omega 2L. L common in the brackets, omega 1 plus omega 2. Fine, minus 1 by C, 1 by omega 1C plus 1 by omega 2C. From here, minus 1 by C if you take common. What is left? Omega 1 by omega 1. 1 by omega 1 plus 1 by omega 2 will be left. This will be equal to what? This will be equal to 0. Because minus r plus r will give you 0. Just added both the equations. Here also you can reciprocate this, cross multiply it. So this becomes omega 1 plus omega 2 into L minus 1 by C omega 2 plus omega 1 divided by omega 1 into omega 2. This whole term is equal to 0. From here, if you look, this term also will go. This term will become what? See over here. This is negative. If I transport this, this becomes positive. So it actually becomes omega 1 plus omega 2L is equal to 1 by C omega 2 plus omega 1 divided by omega 1 omega 2. This term gets cancelled. Value of omega 1 into omega 2 I am getting as 1 by LC. This is the first thing that I require. Second thing that I require is by subtracting these two equations. This was by adding these two, no? Here I had added these two. Now I'll subtract these two, 1 and 2. So if you subtract 1 and 2, if you subtract both these, see, everything will be the same except for this negative sign. L will still be common. Here take 1 plus 1 by C common, because here you will be left with 1 by omega 1 minus 1 by omega 2. Just a negative term will come, no, wherever positive was coming. Now this won't be equal to 0. Here it will be R plus R minus R. That gives you what? 2R. Got it? So here it will be 2R. This time it cannot be 0 because we are subtracting and the signs get changed when you subtract. So from here omega 2 minus omega 1 into L, take the LCM common here as well. This becomes omega 2 minus omega 1 divided by omega 1 into omega 2. This is equal to 2R. Got it? What did we do over here? We have just cross multiplied these two terms. I'll repeat once again when I'll write down at the end. Now see class, if I just multiply this term, L plus omega S, means if I take common from here, what will be left? If I just keep this all along, This becomes omega 2 minus omega 1 into L plus 1 by C omega 1 omega 2 from here. And this is equal to what? This is equal to 2R. See, what did I do? What was the formula? What was the value of omega 1 omega 2 that I was getting? Omega 1 omega 2 from the above part. I got it as 1 by LC. That only I have kept around. That gave me C1 by C by 1 by C1 plus C2. So from here, if you just put this value, omega 2 minus omega 1 has been taken common. What is left? L plus 1 by C omega 1 omega 2. Right, class? From here, I have taken common this term. This is left L plus 1 by C omega 1 omega 2. And omega 1 omega 2 came out to be 1 by under root LC. Remember from here, omega 1 omega 2 is equal to 1 by LC. So if you put it over here, you just get omega 2 minus omega 1 L plus 1 by C. Instead of omega 1 into omega 2, put 1 into LC. CC gets cancelled. This becomes 2R. Omega 2 minus omega 1 L plus L becomes 2L is equal to 2R. 2 gets cancelled. Omega 2 minus omega 1 comes out to be R divided by L. Secondly, most important thing that is required. Omega 1, omega 2 minus omega 1 is R by L. Two things we have, omega 1 into omega 2 is 1 by LC. Using that, we had concluded omega 2 minus omega 1 is R by L. Now, Q as one of the formula of Q that we are already aware is, Q is what? Omega R divided by omega 2 minus omega 1. This can be written as omega R. Omega 2 minus omega 1 can be written as R divided by L. One formula is this, which this also you can use if it is required. This also can be used. Along with it, one thing, see, this is also one of the formula that is derived using this. But we will lead to one step further. Omega at resonance is what? 1 by under root LC. Square both the terms. Omega into omega R becomes 1 by LC. Agreed? Squaring both the terms will give me square of this only, and it will vanish this root. Just interchange 1 omega R in the denominator and L in the numerator. You can still write it omega R into L is equal to 1 by omega R into C. No doubt, you can still write it. See, class, from here, if you look at this formula, omega R into L is what? Omega R into L is Q into R. So you can write Q into R as 1 by omega at resonance C. Q comes out to be 1 by omega at resonance RC. And what was omega at resonance? It was 1 by under root LC. Q was, so this will be 1 by, this becomes under root LC. Here you already have RC. Under root RC, if you rationalize this, finally you'll get 1 by R will be left outside. Under root L will be left in the denominator, but this root will come for C in the denominator. This is one of the formulas that is required. Yeah, I'll repeat just the steps once again. Steps are easy. C class, these steps are not difficult. It's just that this is a lengthy one. Chances of this coming are a little less. Just see into your classrooms, whenever the teacher will tell you. So half-yearly exams can be predicted by that. Regarding the board exams, these are less asked. Z was equal to what? Impedance was equal to root 2R. And the value, if you put the value of impedance, you got one of the equation as omega 1 L minus omega 1 C plus R, and omega 2L minus 1 by omega 2C as minus R. These two equations. First, tell me, class, till these two equations, do you have any doubt? Clear?
No doubt.
All right. So if this is clear, if you add these two equations, you get the value of omega 1 into omega c as 1 by LC. When you will copy down, wherever you will be having problem, ask me. So by adding them, you'll get this value, omega 1 into omega c is 1 by LC. When you will subtract these equations, you will get the value of omega 2 minus omega 1 as R divided by L. Using simple mathematics, it is lengthy, but the mathematics used is very easy. Neither integration nor differentiation, nothing is used. Simple algebra is used over here. We also have the value of Q. So we get the value of Q as omega R into L divided by R using these two values. We have the value at resonance, we have the difference between them. Why did we calculate? Why did we add them to get this value? Because this value got ultimately utilized in the subtraction part. Here it got utilized. So for solving this, we had to find out the product of omega 1 into omega c, and that would be calculated using addition. Once you have this value, put it into the formula omega r square. If you write anything as square, omega r square means what? Omega r into omega r. That only I have written. And squaring this side, the right hand side, it removes or vanishes the root. From here, omega r L was written together and omega r C was written together. Using this omega r L by R, I could write omega L as Q into R. Q into R as omega RC. From here, I put the value of omega as 1 by root LC. So from here, I got the value of Q as 1 by R under root L by C. Any doubts in the derivation? Any step? Addition part, subtraction part? Clear to others as well apart from Khalid, or only Khalid has understood?
Clear, ma'am.
Yeah? All right. So note it down wherever you're not able to understand in the addition subtraction, because some of the steps I have told you and I have not written it. So it may happen that you're not able to understand how did the addition or subtraction occur. So either text me or just ask me. See, this question says what? In series LCR circuit, resonant frequency is 800 hertz. So resonant frequency means omega R is given to you as 800 hertz. And the frequencies either at the either sides of the graph, which we call as omega 1 and omega 2. So omega 2 is given as 855 hertz and omega 1 is given as 745 hertz. So bandwidth and Q factor. See, Q factor is equal to omega R divided by omega 2 minus omega 1. This becomes 800 divided by 855 minus 745. This comes out to be how much? 800 divided by 0, 1, 110. So this will be 77 point something, 7 point something, no, 11 into 7 is 77. 7.27 something around this. And it's a unitless and dimensionless quantity because frequency is above, frequency is below. So it will get cancelled. Regarding the band frequency, it's omega 1 minus omega 2. So bandwidth omega 2 minus omega 1 is 855 minus 745. This will be in terms of hertz. Fine, note this down. All have written. Hania, Khalid, Salman, you also have written?
Done.
Yes, ma'am.
See, two kinds of circuits were left. We have done individual circuits, meaning AC circuits containing only resistor, only inductor, only capacitor. These three circuits. Then we have done what? LCR circuits. So 4 circuits were done. You have 6 circuits in your course. 2 circuits are left. LR circuits and RC circuits that I'll discuss. LCR circuits we have done only R, only L, only C. 3 circuits plus 1. 4 circuits we are done with. Now we'll do series LR circuit first. This is series LR circuit. LR circuit means what? You have L and you have R. That is a circuit having a resistor along with an inductor. This is connected to a AC dynamo coil with value E naught sine omega t. This is resistor, this is inductor. So yes, Samira, what's the phase difference between the current and voltage in case of resistor? The circuit containing only resistor. What's the phase difference between current and voltage, Samira? Yes, Samira. Phase difference between current and voltage. What's the phase difference between EMF and I in case of a circuit having only resistor? Khalid?
Yes, teacher.
Phase difference between current and voltage in case of AC circuit having only resistor.
Same phase.
Same phase, exactly. Same phase. Both are in the same phases. We have done it so many times. And Hania, what's the difference between them in case of inductor? Yes, Hania.
Ma'am, can you repeat?
Phase difference between current and voltage in case of AC circuit having resistor, inductor. Are they still in the same phase? One is leading another, something like this. Which one? If you will not remember this, then how will you answer all the questions? I have told you in the starting only that remembering at least which have the phase difference between them is the basis of this lesson. You people are still not aware about the fact whether which quantity is leading the other rotating vector by which amount. I have told you it so many times that in case of resistor, both current and voltage are in the same phase. No phase difference is there. In case of circuit containing only inductor, voltage leads current by pi by 2. And in case of circuit having only capacitor, current leads voltage by pi by 2. This diagram also, I have repeated it so many times. When we were doing individual circuits, that time also we had done. When we were doing LCR circuit, this time also at every step we were discussing this fact that which quantity leaded which quantity. This also I had shown you that in resistance both are in the same phase. In case of series circuit containing only inductor, EMF leads, voltage leads by 90 degree. In case of series circuit containing only capacitor, current leads by 90 degree. Without this information, how will you be able to solve any of the questions? I'll soon take a test of AC. Start revising. In the next week or next to next week, I'll take a test of AC. So it's better if you all start revising. So in case of series circuit, only inductor. Voltage leads the value of current by pi by 2. Remember this value. You can remember this with the help of the phasors also. Phasors also we have seen when we were doing these circuits. I have told you that whenever you are solving these circuits, just look at the phasors. By that, you will be able to draw the graph. This also we have done it separately. Current lags, voltage leads. Both are in the same phase. See, by this you can easily remember. You can see current is leading. So you will be able to draw the graph. You will be able to write down the formula and you will be able to draw the phasors as well. Start revising, otherwise this chapter will become very difficult. It's a short lesson. If you don't study this lesson, it will be very difficult to answer. So from here we have value of E as what? E is E naught sine omega t. So if current is I, voltage is this, and resistance is this. So I can relate all three using Ohm's law. VR is equal to IR and VL will be equal to XL into I. That's how we write it. From here, Even if you want to draw the phasor diagram. If you wish to draw the phasor diagram, if your voltage is here, E naught, this is your voltage. This time what will happen? Or let's say this is not voltage, let's say this is value of resistor. This is the value of resistor, or you can say VR. So here what is happening? Your voltage is leading the current. So you will draw for an inductor. Remember, for inductor we always draw the graph here. For capacitor we draw it here. So you can write it in this way. So this will be 90 degree. The angle between them will be 90 degree. This part will be, if this is this part can be phi, that you can take it on your own. This you can write it as pi by 2 if we draw it a current also over here. Now the main derivation part. This is now easier to understand if anybody of you has studied LCR circuit. Whoever has revised will be able to recall this. In LCR circuit, this is easier than LCR circuit. In LCR circuit, you had three things. Now you will be having what? In your net EMF square in the impedance triangle that you will be having. Your net impedance, even if you do not write the net impedance, your net value of EMF this time will be what? It will be simply VR plus VL whole square. Like this it will be. Because you do not have the third quantity capacitor over here. So E naught square will be equal to what? From here you have I naught square R square plus XL square I naught square. Right class? VR is equal to IR, VL is equal to XLI. Take I naught square common. What is left? R square plus XL square. I naught square is equal to E naught square divided by R square plus XL square. I naught is equal to E naught divided by under root R square plus XL square. So do you notice instead of XL minus XC or XC minus XL, this time you are just obtaining the value of impedance as what? The impedance for a series LR circuit is simply under root R square plus XL square. This is the value of the impedance for the series LR circuit. Fine, you just don't have the value of capacitor with you. So this eases your question. And XL, you can write it as omega L also. Even in case of tan theta, tan phi that we write, you just have to write in terms of VL divided by VR, or you can write XL divided by R. You don't need to write XL minus XC this time. Fine. So it will make your question easier. So E was what? E was equal to E naught sine omega t, and I will be equal to I naught. This is just a revision. I naught sine omega t minus phi, whatever is the phase difference. Fine, these two are the formula for it. We'll just do a question on this. First, note it down. See, a resistor is connected with an inductor. So voltage of the resistor is what? 90 volt, and the voltage of the inductor, this is given as 120 volts. IRMS is given as 3 amperes, and you have to find out the impedance. Now see, for finding the impedance, we have to have the value of ERMS as well. Unless and until we have the value of ERMS, we won't be able to find out the value of IRMS. So see, for VRMS, we have to find out the net resultant voltage will be what? It will be VR square plus VL square. From here, we had only started the derivation. So this will be 90 square plus 120 square. So this will be 150 volts. Now IRMS is 3 amperes. So in the first part, you have to find out the value of impedance. Impedance Z will be equal to what? Z will be equal to VRMS divided by IRMS. This will be equal to 150 divided by 3. This is what? 50. This will be 50 ohms. Secondly, phase angle is asked with you. So phase angle tan phi, you can write it as what? Excel also you can use, but Excel we do not have any information regarding the inductance value and resistance value. So we'll write it in terms of voltage only. VL divided by VR. VL is what? 120. And VR is what? 90. So this becomes, this is also 4 by 3. So phi will become tan inverse 4 by 3, and exactly the answer that you were getting, no, Khalid, 53.3 degree, 1.33. Same answer it will come. All right, class, note it down. So this is also, this is one of the circuits. One circuit is there that we'll discuss. So see, class, this is easier. One of the components got reduced, so rest of the thing remain the same. We are doing the same thing again and again. So if you do not revise it, then there's no benefit of doing this part at the last to make your work easy. We start revising it on the, this is what? It is Monday. So Monday, then we have class on Wednesday, then we have a class on Monday, then Wednesday. Next to next Monday, that is 12th September, I'll take a test. 12th September, I'll take a complete test of AC. Not 12th. This Monday, it is 29th. Then we have 30, 31. So Wednesday, most probably we'll try to complete. Monday, you can get a gap. On Wednesday. Okay, fine. 12th September, I'll take the test.
Or you can
Else,
take like next Wednesday, you know, it's okay.
sure.
Yeah, it's okay. Next Wednesday.
Next Wednesday is okay. It's better if it's next Wednesday. But do revise and come. All right. 7th September, I'll take the test for full this lesson. So now the series RC circuit, this is the last circuit as well, and this is the last topic for today as well. So resistor is R, VR will be equal to what? This will be equal to IR. Both are in the same phase. And in case of capacitor, voltage lags by 90 degree. Please remember all these things. Till 7th means this Wednesday it is 31st, the next Wednesday you will be having the test. So a lot of time is there. This whole weekend also you will get, as well as more than a week you have. And this is not a very lengthy topic. This chapter is not very lengthy. You just have to understand which is leading what. Rest of the things get built up easily. If you're having any doubts, any part you want me to repeat, just study as you will keep on studying. Whichever portions you will be having difficulty, ask me. So this will also be E naught sine omega t. Fine. So now instead of resistor and inductive, you have only resistor and capacitor. There are other circuits as well, but those are not included in your syllabus. LC circuits, then all different types of circuits. So here what will happen if you draw this now? If this is the value of EMF, let's say, and this is the value of VR that I draw. So VC will be lagging behind. Here it will be. So this will be the type of Euler thing. Angle will be 90 degree. One will be omega t, other will be phi, phase difference, omega t, and all these things same. EMF will be equal to EMF square will be equal to what? This time it will be equal to VR square plus VC square. This you have. So E naught square will be equal to I naught square R square plus I naught square XC square. Take I naught common from here, I naught square common, you are left with R square plus XC square. Based on this exact pattern as we have done. So I naught square is equal to E naught square divided by, this is R square plus XC square. This is R square plus XC square. Now I naught square from here, if you take common, not common, if you take the brackets, the square, this will be equal to what? I naught will be equal to E naught divided by under root R square plus XC square. And Z will be equal to R square plus XC square under root. This is the impedance that you will get. So instead of XL, you will be having XC. In a LCR circuit, you have the difference of the square. Now tan also, when you will write tan phi, this will be VC divided by VR, which can be written as XC divided by R. This you can use. Fine class. So here an XC, obviously you can write it in terms of 1 by omega c. Similar to what you have studied, it's just that here you have impedance as XC in terms of XC. All right, quickly copy this as well. This was the last circuit that was left. Done, class? Just text me done in the chat box when you've written.